Welcome back for another exciting video about our seismic velocity model building technique that we refer to as FWIME. This is the first part of our lecture series entitled Theory and Design, and the goal here is to explain the intuition that led us to design our algorithm. In this first part, we will describe the three fundamental tools necessary for the success of FWIME. We would like to first introduce ourselves. This picture was taken in our office at Stanford University. My friend Ettore on the left is from Genoa in Italy, and I am from Nice, France. Moreover, in the past 4 years, Ettore and I have collaborated on many different projects, and today we are really excited to tell you more about FWIME. Just to summarize the structure of our lecture series, we saw in the introduction video that we will decompose our work into 3 parts. In the first part, Theory and Design, which is what you are currently watching, we will show you that the FWIME cost function is a combination of the conventional FWI objective function with a wave equation MVA objective function. In the second part, we explain how we minimize our objective function and how we need to incorporate our model space multiscale approach to improve FWIME's convergence properties. And in the third part, we test FWIME on benchmark numerical test. This is the FWIME main storyline summarizing the agenda we just saw. We will use this slide along the way so that you can keep track of where we are in the presentation process. So we are now in the theory and design part. And the first point I want to address is how we built our objective function. Let's recall the conventional FWI objective function. We have our current model estimate, M subscript I or MI. We have our predicted data, F of MI, and we have our observed data. Here, F corresponds to the acoustic isotropic wave equation operator extracted at some predefined receiver's position. The FWI objective function is proportional to the L2 norm squared of the difference between the predicted and the observed data. It is widely known that this large dimensional problem is highly nonlinear. However, if M subscript I is close to the true solution, it may belong to the convex basin of attraction centered around the global solution, in which case a gradient descent method would lead us to converge to the optimal solution. However, if MI is far from the true model, and we use a gradient descent method to minimize this objective function, we are very likely to get trapped into a non-useful local minimum. The rule of thumb is that for any given event in the data, the observed and predicted traces should not differ by more than half a cycle from each other. And by cycle, we mean the cycle of the dominant frequency. And not satisfying this condition is referred to as cycle skipping. In FWIME, in order to mitigate this cycle skipping effect, we add a data correcting term to the argument of the FWI objective function, g of mi. Its goal is to ensure that f plus g always matches the observed data as accurately as we wish. However, being able to match the observed data with this additional term does not imply that our objective function is convex or free of local minima. Therefore, we add a penalty term to our objective function in order to make the data correcting term vanish. And we gradually reduce its contribution over iterations. In fact, at the end, if we satisfy f plus g equals d observed and g has vanished, then our FWIME inverted model coincides with the global minimum of conventional FWI. In the following, we call the first term the data fitting term, and we call the second term the annihilating term. The intuition behind the design of our objective function is the following. First, we can see the data correcting term g of mi as a tool to reduce and control the relative weight of the data fitting term with respect to the annihilating term in our cost function. On the other hand, this annihilating term gives us the freedom to design clever operators, or annihilators, that can guide our inversion to the global minimum more carefully and more robustly. Okay, back to our main storyline now. We're still in part 1, Theory and Design, and we just finished talking about our objective function. And in the next video, we're going to talk about how we build our data correcting term. Okay, so this is the end of our introduction video. We hope you enjoyed it and that we made you want to discover more about our technique FWIME. If you have any questions or comments, do not hesitate to contact us directly. Furthermore, if you're interested in watching more videos and accessing regular updates on our work, please visit and subscribe to our YouTube channel called EG Optimization.